Hello and good day. Thanks for coming to my session on DevOps governance with Terraform. I'm Jim Counts, a technical fellow with this alliance. But before I started working as an infrastructure architect, I spent many years as a developer, primarily in C#. But over the years, I became more and more interested in automating the development flow, and it kind of became a niche for me. I remember the first time that I created a CI/CD server under my desk on an unused Dell desktop, and I was pretty much hooked from then on out. So what I want to talk about today is DevOps sprawl. It's a real thing. I've seen it at large organizations, especially those that are working on decomposing their old monolithic apps into microservices and moving to the cloud. As this decomposition happens, a large organization is going to end up with many teams, and those teams are going to have different responsibilities. Primarily, though, you're going to see a big divide between platform teams that automate the governance, networking, and shared services, and application teams that deploy specific applications. And those applications may come with infrastructure of their own, but they need a landing zone in order to put that infrastructure, such as databases and queues and other items like that. But they don't need permission to manage the entire cloud environment. So we have to consider, when building out a team like this and granting these permissions, like, what are the good principles that we should follow? We know that there's good coding principles like decomposition, modularity, single responsibility. Organizations on these journeys to decompose monoliths are aiming for these. So we would expect that as the monolith decomposes, that we're going to find, teams are producing more and more NuGet packages, more and more, infrastructure projects as they decompose along the lines of their specific domain responsibilities. And that's because, we want our teams to be able to operate independently as much as is reasonable within, the guidelines of our own security and audit framework that we have to follow. But all of this is going to lead to more and more DevOps project and more need for DevOps. You can have more projects. In the case of ADO, that might even be top-level projects, right? Those projects gonna have more pipelines, and each pipeline should have the right credentials for what it needs to do and not be overpowered, right? We do want to follow those good security principles, like the principle of least privilege. So it all starts to get pretty complicated. And it can happen fast or it can happen slow. But as this decomposition happens, that sprawl is going to follow it. And we're going to find that teams are having difficulty dealing with this sprawl. And it brings to mind this meme that we've all probably seen about desire paths, where we see that the one person is not walking on the path that was laid down by the designers, but instead is taking a shortcut across the grass. So in urban planning, this has a name, and that's desire path. And the pedestrians are choosing the path that's optimal to them rather than the path that the original designer wanted them to take. And our administrators are the pedestrians in this case. They're facing a lot of sprawl, and they may start taking shortcuts that we would rather they not take. So if they have too many credentials, they may decide to share them. We may have a rule that says they should not be using wildcard certificates. So if we have too many host names, managing those certificates becomes difficult, and so they may give in and decide to start using wildcards. And again, the same thing goes for DevOps projects. As more and more projects get created in DevOps, the temptation is to simplify that to a more manageable level by perhaps adding unrelated projects into the same area, so that there's just one less thing to configure down the road. And I'm sure there's more that I'm not calling out here, but you get the idea. So we may not condone people taking shortcuts, especially shortcuts that leave our system in a less governed state, overpowered credentials, etc. But we can understand that the problem they're facing is the complexity of managing according to the principles we've given them. So according to urban legend, In many cases, urban planners, when they see those desire paths that we saw on the last slide, they'll go ahead and just pave it, right? And they'll recognize that perhaps they didn't come up with the optimal solution first, and they'll just make it easy for the pedestrians to go the way they wanted to go. And this is, recognizing that there was a problem in the original design, as opposed to just trying to enforce a policy like putting up a sign that says keep off the grass. So if we find that our administrators are taking shortcuts, they're not managing the credentials the way we want them, the certificates are being overloaded and overused, we have to assume that if it was easier to do the right thing, that they would do it, that they're not just doing the wrong thing because they feel like violating the policies. In fact, violating those policies probably stresses them out to some extent. So we need to make doing the right thing easier, and I think that's where Terraform can help us. So what do we really put into a typical Terraform project that's managing Azure? We might have an Azure storage account to hold our remote state. We need a pipeline, and our pipeline is going to need a set of credentials in order to operate against Azure. And if we're using Azure DevOps, we're going to need a DevOps project, and it's going to need some variable groups, a few pipelines, service connections to connect to the various systems that need to be managed. And finally, we need an environment to manage. So, maybe for an application team, one or more resource groups that they're allowed to manipulate. And for our platform team, they might have the authority to manipulate the whole subscription. And the question is, well, could we manage all that with Terraform? And the answer is we can, because for each of the things that we need to work on, storage accounts, for example, that's just the Azure Resource Manager, Azure RM, Service Principals credentials. We're going to get those from the Active Directory, support from Azure AD, and service connections, pipelines, DevOps project. Those can all be managed with the Azure DevOps provider in Terraform. So this brings us to the idea of the title of this talk, which is we have launch pads and landing zones. So a cloud landing zone provides a centralized and managed experience for application solutions to land in the cloud. But it should be pretty clear that you can't really achieve that centralized management without some kind of tooling. And so there's a tooling environment behind it all that helps you get into that landing zone. And so that's the launchpad. So if you want to govern everything with Terraform, your very first launchpad is going to need to be some kind of tooling environment that's capable of running and managing Terraform. So that's the root environment, the first launchpad. Its job is entirely to create other tooling environments, other launchpads. We're going to look at the way that we can use launchpad to manage a pure infrastructure project or a pure application project, and we'll look at a hybrid project. Those tooling environments created by the root environment are the environments that manage the live environments, and that's kind of a bit circular to wrap your head around, but basically what it means is that, in the case of an application team, they're going to need to be able to run some Terraform in order to, say, deploy a SQL instance. Well, to do that, we want to provide them with a fully configured tooling environment, meaning we want to give them the pipeline needed for them to run that code that will deploy the database. We don't want to deploy the database for them. We want them to be able to make that decision. So what we're building is the tooling environments with our initial root launchpad. Those tooling environments give teams the tools that they need in order to run their own solutions. There'll still be, to some extent, the same amount of sprawl, same amount of credentials, same, additional certificates, etc. But if all of that is pulled into Terraform and managed, we can get the benefits of following those principles while taking away some of the complexity of spinning it all up. So our root tooling environment, the one that builds all other tooling environments, looks a bit like this. And so if we take a look at everything we have here, there's a few prerequisites that we don't actually build with Terraform because Terraform actually can't build them. And so our initial subscription, we'll have to create that. There's no way to create a subscription with Terraform. And our DevOps organization will need to be created. And of course, our tenant our Azure tenant is also pre-existing. But once we have those items, we can build the rest of this. What we're trying to create for the root project is a pipeline that's capable of creating other projects, resource groups within our subscriptions, and objects within our Active Directory. So the pipeline is the main star of this show, and we're going to configure it so it has the personal access token it needs in order to manage DevOps, the Active Directory roles associated with the service principal in order for it to manage Active Directory and create objects there, and the right Azure RBAC roles on that service principal for it to manage this whole subscription. The project will also build for us the Azure RM service connection and a service connection back to our source code, which in this case is stored on GitHub. And as we talked about, there's several variable groups providing the different credentials and where Terraform should find its backend, etc. Inside of the backend itself, though, we have a few items that are important because we're going to see this a lot as we build out tooling environments. To support Terraform, right, we need a state file, local storage location. This is optional to encrypt that state file with a custom managed key, but in the case of this demo, I do that. So there's a key vault in this backend, and that key vault provides the custom managed key to encrypt the state file. And both of these resources are feeding their audit information into a log analytics workspace. So how do we get started building that is probably a valid question. We want to build all of that initial tooling environment with Terraform, but we need some way to run Terraform in order to build that tooling environment. We've got a chicken and egg problem, and we have a few options for how to overcome it. So the first option would be a completely manual approach where we click around in the portal or write a bash script or something like that. This is a quick way to get started. You should only need to do it once, because after you build that initial root backend, you'll be able to build additional backends using Terraform. But of course, the con of this approach is that you're not using infrastructure as code. It'd be better to use Terraform, and so you would write up, the Terraform scripts you need in order to provision all of those backend resources, and you would just have to run it from perhaps your local machine in order to get that stuff created. But if you're just running that manually on your laptop and you're not using pipelines, then you lose some of the benefits of running all that through pipeline. So a full bootstrap is probably where I would recommend most people go, which is to build everything once, like from your laptop, and then once all the pieces in place, just reconfigure your Terraform project to start using the remote backend, and from then on out, use the normal workflow of writing code, checking it into Git, triggering pipelines, and deploying your changes through Azure DevOps. Now, I originally wondered if maybe this full bootstrapping idea was kind of crazy, but I've been reading around, and it's not that crazy. Now, can you run into trouble this way? I mean, yeah, you can. I mean, is it possible to shoot yourself in the foot by taking your root governance project and bootstrapping it into Terraform pipeline, and then using that same Terraform pipeline to manage its own backend? Yeah, the answer is a definite yes. You can shoot yourself in the foot that way. But on the other hand, you can shoot yourself in the foot clicking around inside of the portal. If you're writing a bash script, and you're not taking advantage of the features that Terraform offers in terms of showing you a plan and giving you the chance to review and back out of that plan, you can shoot yourself in the foot with a bash script. So the point is that when you're dealing with infrastructure, you can shoot yourself in the foot. And I certainly did that while developing this demo. I had been fooling around with the custom managed key inside of Key Vault. I think I wanted to see how Terraform would react if I manually generated a new version of that key, and the answer was that it continued to work, but I think it created some plan noise. So I decided to get rid of that key, and when I got rid of that key, of course, I ended up losing my ability to access my remote state. and I had to go ahead and tear everything down and start over. So let's take a look at what the code for that root project looks like. And I've got the code loaded here in VS Code. There's a few top level areas in my governance project, and so I've got some shared modules, which are various components that we'll see how they get put together in later solutions. But we'll see a few of them right now in the root project. We've got the pipeline templates. I'll take a look at the pipelines in a moment. And we've got the projects themselves. Well, there's a project which manages projects. So inside this folder are all the different different solutions that I'm governing. And in my case, of course, most of them are demos or lab environments that I'm using in order to explore different implementation ideas. But root is the one we're talking about right now. So projects contains a Terraform project. We see it has its own main with a couple locals in it. There's Terraform root, which is a module call which creates the root environment, the root DevOps launchpad. So besides taking in the variables that it's going to need to build, we can see that this module, the submodule of the main module, is pulling in various things that the root project will need to build in order for it to self-manage itself, but also manage other environments. So again, we've got a kind of a basic main. We've got the backend here. So this module creates the backend resource group and puts those resources in there that I mentioned, like the key vault and storage account. We've got this Azure DevOps Pipelines, which actually manages the configuration of the Azure DevOps project itself beyond just the pipelines. So we've got the backend config itself, the main branch that the pipeline should watch inside this project, and a few other values that are important to us. And we define one pipeline for this project, which is the Terraform root project. And again, provide the necessary credentials for the project in order to manage itself. Now, there's some other credentials mentioned here, like this Azure credential. So the Azure credentials are the service principal. So by invoking this module, this Terraform project will go into Azure Active Directory and create a service principal and generate a script for me that will assign these Active Directory roles to that service principal. Now, this script can't be applied directly by Terraform through the Azure AD provider. It needs to be run by a trusted administrator, such as myself in this case. But it could also be run by Terraform if we, for example, created a null resource to run that script. I just haven't taken that extra step yet to fully automate that piece. The last piece we have is one more variable group for AWS credentials. This is because most of my infrastructure is in Azure, but my DNS is actually over in Route 53. So for demos where I need to manipulate DNS, I find it necessary to use the AWS provider in order to set that up for myself. So when we run this project, we can run it like any other Terraform project. So we just go to like CD projects, and I have a make script that will help run a plan, Terraform init, and so forth. And there shouldn't be any changes at the moment to this project because because everything should all be set up for the governance of the root. But if I do make any changes, I might only look at the plan here but not apply it. And I would then head over to Azure DevOps to run the associated pipeline. And so to take a look at that, we have this Terraform root project. It's only configured to run pipelines because our source code is over in GitHub. So we've run this pipeline a few times, and if we take a look at it, We can see that it's all YAML based. We've got the calls out to our pipeline templates, where we are going to go ahead and inject our Azure credentials into the pipeline. We're going to grab the version of Terraform we want, run Terraform init, create a plan, and publish the plan so that it can be deployed in a later step. So there's a setting in this project that requires the deployment to be approved, and so I would have to stop and approve it there. But once I approve it, the deploy stage will run. It will grab the published plan. Again, it'll grab the correct credentials, and Terraform, again, because this will be running on a different build agent than the first agent that we used, and it will run the Terraform apply for us. And we can see all those steps, including our ability to review the plan before deciding to go ahead. And so, here's a few changes that were made last time that I was getting ready. Just updating a few of the resources that were previously missing. So, and when we apply that plan, we can see a few of the same steps and the steps that I outlined, and all those changes were made and applied successfully. Once we have a root project, again, the purpose of the root project is to build tooling environments for other projects that support solutions. So it's our tools in order to build tools. It's our factory in order to build other factories. What does it look like to add another tooling environment, another launch pad to this? So that's what we'll talk about next. We'll look at a simple solution that is a pure infrastructure only launchpad and landing zone pair. Again, a lot of the things that I'm managing under this project are my own demos and own lab environments. So the goal for this particular launchpad was to create a managed environment for another intro to Terraform pipelines talk that I give. This is just only needs to demonstrate the capabilities of Terraform. There's no applications involved. And that solution looks like this, which is basically the landing zone for this solution needs to be this resource group, right? Because what the imaginary team in this case, or the demo, needs to demonstrate is the ability to deploy these objects in there, the virtual machine and the things that go with the virtual machine. As well as the networks, right, and the NSGs and the public IP address that goes with it. So a very simple solution. How would we build a launchpad to support deploying this solution? Well, the things that we need that were not shown in that picture in order to make that picture possible are a backend resource group, which is very similar to the one for the root project. But we need another Azure resource group, the actual resource group that solution is going to be deployed into, because our backend resource group is only for tooling. We'll leave it empty because it's not our job to fill that resource group. It's the team deploying that virtual machine's job to fill that resource group. We'll need to give them a service principal with the correct rights on the correct scope. And when I say give them that, I just mean associate that service principal with the pipeline that we provide for them. And in order to provide a pipeline, we'll give them a DevOps project. That project will have a pipeline, service connections, and variable groups in order to pass those credentials securely to the team. And so this is what the total solution looks like in order to support deploying that VM. We again start with some source code. It's still over in GitHub. We provide an Azure DevOps project, which has a pipeline in it. There are fewer variable groups because there are less lines of management for this project. So this VM project doesn't need to manipulate Azure Active Directory. It has a service principal provided by the root, but it has no need to create service principals of its own or groups of its own or change group memberships or anything like that. So we see Azure Active Directory as part of its tooling requirement, but we don't see any management line pointing at Azure Active Directory because this project doesn't need to do that. In the same way that there's no management line pointing back at Azure DevOps. Again, this project doesn't need that. On the other hand, they do need to manage the Azure environment. And so there is a management line pointing there, and that's, those service principal credentials are embedded securely in this Azure RM service connection that the pipeline is using. So let's take a look at what that looks like in code. We will find that this particular solution is the one called Terraform Pipelines. And again, like the root project, it has a top level call to its submodule where we pass in the things the submodule needs. And then over in the submodule, we can see the items that it's configuring. And as mentioned, there's a few less things being configured here than there were in root. But we still have the backend call. And again, it's kind of obvious here, but maybe not obvious in the diagrams, that this backend call is, although looks the same because it's a module, they're both calling the same module, it is in fact a different instance of the backend. So Terraform Pipelines gets its own instance, its own storage account, its own private location for storing that state with no access whatsoever to the root state, which again is very important because state is very sensitive. Similarly, we have its own set of credentials, and the owner scopes for this set of credentials are just those two resource groups that we mentioned, as opposed to the root, which has owner scope of the entire subscription. So this team is restricted to manipulating these two items. We have a pipeline that will run this VM deployment. It has very similar items here. Again, it's its own instance, has a slightly different name. And the Azure environment itself. Again, our Azure environment in this case is an Azure resource group environment, so it just creates a resource group and tags it for us and leaves it empty. So that was the infrastructure only solution. The next thing we're going to look at is the hybrid solution, where we have applications and infrastructures to deploy. The hybrid one is going to bring us to another level of complexity, and is actually a really good learning experience for myself, because as I built it, I began to realize that DevOps sprawl and infrastructure data were not just about Terraform. So in the hybrid launchpad and landing zone, again, I have a very similar goal. This is another one of my demos for a different talk, which is that I want to create a managed environment for a talk that is about deploying containers to Azure Kubernetes Service. So in this case, I wanted to also show like the promotion path of, having like a dev cluster and a prod cluster. So there was a pair of clusters I needed to build. And then I also needed to be able to demonstrate, the actual container deployment pipelines. That talk's not about infrastructure at all. It's about deploying those containers. So really, this entire launchpad and landing zone are just what happens behind the scenes before I start the talk. And so I need the infrastructure pipelines for myself so that I can manage this environment. And I need the application pipelines to exist so that I can show those during the talk. So a kind of simplified view of that. I don't show both sets of clusters, but a simplified view is that we have, again, a resource group, which is our runtime environment. It's got public IP address pairs, and it's got application gateways, one for dev, one for prod. And it's got virtual networks and subnets for the Kubernetes cluster. So there's a pair of those. Now, what becomes interesting on the back end, we find some new resources we didn't see before. This key vault is a separate key vault for sharing infrastructure data between Terraform configurations, because this solution is actually broken up into several layers, as well as sharing infrastructure data with the actual runtime environment. Terraform is the one who takes the information stored in this key vault. In this case, I'm talking about certificates because this solution uses HTTPS. So it would take that HTTPS certificate out of this key vault and, for example, configure it on the app gateway. And we also have a container registry in this backend. when I said that I learned something about infrastructure data and DevOps sprawl, this is kind of what I'm talking about. We can clearly see that the Terraform state is infrastructure data. Building this solution made me realize that there are other kinds of infrastructure data. Certificates are infrastructure data. Container images are infrastructure data. They don't, in my opinion, belong in the runtime environment, because the runtime, and we want to make sure the runtime environment is as ephemeral as we can make it. So if we have a reason to tear down the dev environment and rebuild it, that activity should not destroy our key vault, which is holding on to our certificates, right? So the same thing goes for the container images. Rebuilding the infrastructure doesn't imply that any code changes have been made. So we should not require that we have to rebuild our container images after we've rebuilt our environment. And if we had placed this container registry in the runtime environment, it would have been destroyed at the same time as the rest of the runtime environment, and therefore we would be forcing ourselves to make those changes. I kind of got here through convenience, thinking, well, I'm tired of rebuilding these container images. But the more I thought about it, the more I realized it was that inconvenience was in fact a kind of a code smell, with the idea of putting the container registry someplace it didn't belong. It should be in the back end, which is going to be more stable over time. So as I talked about what was in there, we have we have a few new items like the container registry and the config key vault. And we have our empty Azure resource group. Again, we have a service principal with the correct scoped rights. We have a DevOps project that is, again, much more complicated than the previous DevOps project. This one sports 15 pipelines in order to accomplish what it needs. And we have service connections. We get a variable group for AWS this time because we needed that solution uses a publicly facing website. So I need to configure DNS for it, both to access the site, but also to issue certificates using Let's Encrypt. So this is what it looks like, everything together. So I did not draw all 15 of the pipelines, but these three represent, the entire group. We have many, many pipelines. There are the variable groups that they are sharing, including information about what the resource groups are, where to find the key vault, where to find the ACR, etc. The AWS credentials come in here so that we can have this management arrow pointing into Route 53. Of course, we always pretty much always have a management arrow pointing into Azure so that this back end can be accessed and this front end can be modified. This solution is configuring AKS, and one of the items that we want to configure for AKS is a Active Directory group for the administrators. So this solution needs to create a group in Active Directory. So we have the management arrow pointing up at Active Directory. So the service principal for this pipeline will get the directory reader role and the group's administrator role inside Active Directory, so that when that infrastructure pipeline runs, it will be able to set up that group for AKS. So I kind of talked about this lesson a little bit. Building this hybrid landing zone, shifted my thinking. Originally I was just thinking that there was a lot of sprawl involved with creating and properly securing Terraform infrastructure pipelines. But now I look at the whole Launchpad idea as a stable backend that we can use to host our automation, where we can put things like our certificates and say that is the source of truth. We can assume that key vault exists and those certificates are populated in there before we deploy our actual solutions. And even if our solution is destroyed, we know that back-end tooling environment was not destroyed with it. So we'll take a quick look at that hybrid project. And let's see. This project is called Container Pipelines. And so it calls a local module called Container Pipelines. And we see that we've got more items in here as expected. The AWS access information to manage Route 53. We build a backend which has all the items we talked about. But again, now we know that there's also a config key vault and in there as well. And we broke out container registry into its own module because not all of our solutions are going to need that. We have a set of Azure credentials. Again, we give roles there, directory readers and group administrator. We have limited scope compared to root. And our pipeline. So in this case, we'll see a fairly big difference. We're passing in a lot of information to our DevOps project this time. So we have our Azure environment, our config key vault location, where to find the container registry, and then our 15 pipelines. And so again, we have the Azure environment, which is creating a resource group for those AKS clusters and virtual networks, etc., to deploy into. And we have support for issuing certificates. Now that we've kind of covered off a few examples of launch pads and landing zones, I'd like to show a demo of adding a brand new landing zone to the mix. So I'm not going to run that here. I'm going to jump over to the Terraform root pipeline and run this branch, this DevOps demo branch, which will generate that tooling environment for me. So Terraform root, and I go to my pipeline, and I run the pipeline, except I'm going to choose, as I mentioned, the DevOps demo branch. And we'll give that a moment to get started. And it should not take terribly long for the infrastructure plan to generate. Pointing out that again, all of this information, all of this code is over there on GitHub. So my user on GitHub is James R. Counts, just like my Twitter handle. And the DevOps governance project is where you'll find this code if you want to take a look. So Terraform root is done creating that backend, so that tooling environment, that launch pad. So all of this is finished. The new project is ready to roll. So I should just be able to come over here and run this pipeline. You can see that the plan, again, this is now, I'm using the tooling environment. So the plan here is no longer related to the governance aspect. This is the actual solution that we're trying to deploy. Again, as the platform engineer in charge of governance, I set up a lot of this stuff in order to create this environment. But as the team in charge of building this VM, the only thing I had to come in here and do was click run on the pipeline. I mean, I had to write my code first, right? But click run on the pipeline, grant those initial permissions for the pipeline to access those resources. And then my infrastructure is already deploying. I just had to write my code and come and click run pipeline, and I was good to go. Our virtual machine already exists, and our gateway already exists, even though it's probably still in an updating state. Our public IPs are configured, so when we get to this point, we should see that, or when we get to the point where it's deployed, we should see something on this IP address. No DNS for this one. Nothing yet, which makes sense. Our application gateway is not finished. Okay, and so through the miracle of time travel, we come to the end where our apply has completed successfully. We can see that everything got added that needed to be added. And over here, we see that the website loaded. So there you have it. It can be just that easy to spin up new projects, and teams don't need to worry about a lot of the complexity that they may have to worry when they're building all of these back-end services by hand. Thanks for coming. I hope you'll reach out if you have any questions, either here or find me on Twitter at jamesrcounts.com. Thank you very much.